Hello everyone, let's solve some Leetcode today. So today we have Leetcode 643, that is maximum average subarray 1. In this problem we have been given the nums array that consists of n elements, and also we have been given an integer k. Now we have to find the contiguous subarray whose length is equal to the k and that has the maximum average value, and return this value. So in simple terms, out of all the possible subarrays of this particular nums array that have the length equal to k, we have to find out the subarray that have the maximum average value. And then we have to return this average value. So we are not supposed to return the subarray itself. We are supposed to return the average value of that subarray. So what is average? How do you calculate it? Simple. The sum of all elements available divided by the number of elements. Now here in the question we have to find out the subarrays for which the length or the number of elements is k. So number of elements in this k will be fixed. So the only thing that will change is sum of the elements in that subarray. So that is what we have to calculate. We will have to figure out the subarray and then we will have to sum everything inside of the subarray, and then we will simply divide that sum by k, and that will give us an average. And then we will have to find out whether this particular average is actually the maximum or not. And at the end we have to return the maximum average. Now let us try to understand this with the help of an example. Here we have the nums array, then we also have the k here, and we have also written the indices for these elements above them. So 1 have 0 index, 12 have the index of 1, minus 5 is at index 2, and so on. Now the brute force way of solving this question is very simple. We just have to find out all the possible subarrays for this nums array, and then we will simply select the subarray that have the length equal to 4, and then we will simply check their average one by one, and then we will simply return the maximum average. So that can easily be done if you have like 3 for loops nested. 2 for loops will have I and j, which will be the starting point and ending point of that particular subarray, and the third for loop will actually calculate the average. So this is how you can actually use the brute force way to basically solve this particular question. But the time complexity for that will be around order of n cube, which is not good. We don't want this. We want something like order of n. That's kind of what we want. So the optimal way to solve this particular question is by using sliding window technique. So whenever you come across questions that actually talk about subarrays, the first thing that comes to your mind should be sliding window, because sliding window technique is designed to go through the subarrays of a given nums array. Now of course we will not go through all the subarrays, and that's the point. We will only go through the subarray that have the potential to be the answer. So we will have here two pointers, L and R. Both of them will start at 0. And we will also have a sum variable. So sum will contain the sum we have in the array till now. So right now we have 1, so the sum will be 1. Then we will increase the R, then R will actually go to 12, then the sum will be 1 plus 12 is equals to 13. So now the sum is 13. Then we will again increase R, the R will be here, that is minus 5, so 13 minus 5. So now the sum will become 8. Remember that we have not calculated the average till now. Then again we will shift here and R will become minus 6. And now 8 plus minus 6 is equals to 2. So now the sum is 2. And here you can see that the number of elements in our range is actually 4. So we have 1, 12, minus 5 and 6, which are 4 elements, and the k here is also 4. So now we have encountered a subarray that have the length 4, and it means we should be actually calculating the average at this point. And also remember that the index right now is 3 here, and here it is 4. So to calculate the length, you will actually do r minus l plus 1. That is 3 minus 0 plus 1. This will be 1. So 3 plus 1 is equals to 4, and we got the length of our subarray. So let's get back to the point. Here we have the sum, and sum represents the sum of all the elements which is present in this particular subarray right now. And then to find the average, we will simply divide this sum by k. So the average will be 0.5. So for now the average is 0.5. Now we can shift the R again. The R will become 4 and we have the element 50 now. So of course right now the length of our array is what? 4 minus 0, that is R minus L plus 1. 4 plus 1 is equals to 5. It means the length is actually greater than k. We have to shift the L pointer. So L will become 12 now. And before we shift the L, we have to minus this 1. So sum till now was actually 2 plus 50 is equals to 52. And this 50 came into picture when we shifted the R here. Now we are shifting the L. That means we are removing an element from the array. So we have to negate or basically subtract the 1. So we subtract 1 and it will become 51. So the sum till now is 51 and L is now here. So now the consideration array is from here to this particular 50. And this also contains 4 elements, 1, 2, 3, and 4. Now we will again try to calculate the average. So the average will be 51 divided by 4 because 4 is the k here. So it will become 12.75. So currently the average is 12.75. The earlier average was 0.5. So of course this is smaller than the 12.5. So we will neglect this one, and the maximum average till now is 12.75. So now the R will shift again. So R will be here, and the sum will also change. So it will become 51 plus 3 is equals to 54. But now we know that we actually increased R by 1. So it means the length of the array is actually now 5 minus 1 plus 1. So 5 minus 1 plus 1 is equals 5. So it is now again more than the k. So we will shift the L again. So L will simply go here, and while we are shifting the L, we will remove or subtract this 12 from our sum. So 54 minus 12 is equals to 32. So the sum right now is 32. And now our window is again valid. So we have window from here to the last place. So we have minus 5, minus 6, 50, and 3 in our subarray. Now we will again calculate the average. So the sum right now is 32, and we will divide it by k, that is 4. So it will be equal to 8. And our previous average was 12.75. So clearly 8 is less than 12.75. So we will remove or ignore this 8, and we will keep this as answer. So this will be the answer because we have now reached the end of our nums array. So R is here. If we actually go ahead, then it will go out of bound. So we can simply stop our code execution now, and we will return this 12.75 as the answer. Now let us go through the code. We have current sum here that will keep track of the current sum we have in the array. Then we have current average that will keep track of the current average that we are calculating. And we have max average that will keep track of the maximum average we found till now. We initialize it with a negative infinity in Python. In other languages, you can use int.minValue. Now we have our left pointer or L pointer. And now we are starting our for loop. So the R pointer will be in the for loop itself, and we are running this for loop for the entire length of nums. In the for loop, the first thing we do is add the nums R into the current sum, so that our sum will be updated. Now we have some checks. So if the number of elements in the window is greater than k, then we know that we have to shift the L. But before shifting the L, we must subtract the value at L index from the current sum, and then we will shift the L. And then we will check if the window length is actually equal to k, that means a valid window. We will calculate the average, and that will be current sum divided by k. And then we are setting the maximum average. So whatever is bigger value at this point of time, whether it is maximum average original value or the current average value that we just calculated, that will become the maximum average value. Now once this entire for loop runs, we know that we have gone through all the elements in the array, and we have figured out the maximum average. So we will simply return the maximum average here. Now let us try to run this code and see what happens. Yep, that's great. We are passing all the 128 test cases. Now let us look at the time and space complexity for this particular solution. The time complexity is simply order of n, and it is because we are going through each and every element in the array only once. And we are able to do this because of the sliding window technique. And now the space complexity is order of 1, that is constant space complexity, because we are only initializing new variables. We have a sum variable, we have an average variable, and then we have maximum average variable. And we have left pointer and right pointer. So we are initializing or using these variables. Now understand that all of them actually have a fixed memory consumption. So it will not change. The memory consumption will not change based on the number of elements that we are getting in the input. And that is why the memory we are using is constant or fixed. So like the video, subscribe the channel. If you have some kind of question that you would like me to target, or you have some kind of topic that you would like me to talk about, then just let me know in the comments. And now we will meet in the next video. Till then, bye.